Hi everybody. In today's class we went through this in-class exercise example problem, and there wasn't enough time for me to demonstrate how to do this with Excel. We solved everything by hand, and those values are available in the recording for today's lecture. But what I wanted to show you here is how you can use Excel to solve all of these same parameters and create a curve that looks like this. And so this is kind of just the typical curve for fixed cost, total cost, a revenue curve, and profit. But I wanted to show you how you could generate something like this yourself for specific conditions that are described here. So just to recap the background of this problem, we are producing some item that has a monthly fixed cost of $73,000, and so those are the expenses like the equipment, the rent, that are unaffected by the level of production. The variable cost per unit is talking about how much material or how much labor or how much electricity, just all of the things that go into producing one additional unit from the line. We have a curve here that describes the relationship between price and demand. And so we know that the only lever you can pull on as a producer to generate demand is lowering prices. And so someone has done a market study, or maybe you've gone back into the archives of past sales history. Someone has analyzed the data, your data, competitors' data, or maybe going to a data broker, and has information that allows them to say what is the relationship between what kind of prices dictate which demands. So I'm not going to go through all of the hand calculations that we did, but let me just show you how we can set this one up in Excel. So I've got a fresh spreadsheet here, and what I'm going to do is define some of our variables up here at the top. And so we've got the fixed cost, C sub F, and that we know is $73,000. I'm going to put per month here. There's also the variable cost per unit. Okay, that's lowercase v. And I'm just going to be real dirty about this. It's $83. I'm not going to put them in the right columns or anything. Price for zero demand. So from the curve that relates price and demand, that's the intercept, the vertical intercept. So what would you have to charge for the item so that nobody buys any? So 180 is that first price at which no one is willing to buy an item. Decrease price by how much to increase demand by 1. So in other words, this is lowercase b. And b is the slope of the price demand curve. And that tells us, in the case of this example, it was 2 cents. So it was saying that if you lower the price by 2 cents, then you're going to sell one additional unit. So what that effectively means is for every dollar that you lower the price, you're going to sell 50 more units than you would have otherwise. Okay, so that is the slope of the curve, and that's 0.02. So I've got these values that I'm going to reference as I put different columns together. So I'm going to have my columns be demand, price, revenue, cost, and profit. All right. Now you won't know at first what values to use for demand. So it's a little bit iterative. Let's say 0, 10, 100, 200, 400, 500, maybe 1,000, 1,500, 2,000. You know, we won't know until we start looking at these other columns exactly what range of demand is going to cause which effect. So I'll just do it through 6,000. Now price is where I'm going to use the curve that we have here, this equation. So for a certain, to have a certain level of demand, what price should we charge? And so it's going to be 180 minus 0.02 times D. Okay, so, wrong curve. That is equal to this. I'm going to anchor the reference to the intercept. So 180 minus 0.02, anchor that reference, times D. All right, so if we want to sell 0, we should charge 180 or more. Nobody will buy at 180. But if we want to sell 10, for instance, then we should set our price to $179.80 per unit, and then we would sell 10 of those according to this equation. So I'll drag this down through all of our different demand levels, and we see what the price is associated with each certain level of demand. Now revenue, remember our definition of revenue from earlier in today's class is revenue is the price, the selling price multiplied by demand. So revenue is how many you're selling and what price you're selling them for. All right, so revenue is demand times price. Okay, so we can see how many dollars we're getting, and it goes up and up and up, but then it starts going down. And we talked about why revenue peaks and then continues going downward. In fact, let me go through a little bit more here. I got 7,000, 8,000. The revenue is definitely going down, and the reason why is even though we're selling a lot, our sales price is so low that revenue has decreased. Okay, cost. Cost is fixed cost plus variable cost. So here is our fixed cost per month. I'm going to anchor that reference, plus the variable cost. And the variable cost is variable cost per unit multiplied by the number of units sold. Okay, so the fixed costs don't matter with the level of production, but the variable cost is variable cost per unit multiplied by the number of units sold. Okay, so we have our costs, and now profit is revenue, inflow, minus costs. Okay, so now with this table, you can see, let me go ahead and format this as currency just because it makes it a little bit easier to see if we've got those commas there, and you know the dollar signs help us know that this is money. Okay, in the example, one of the things we calculated was the break-even points, and so you see how our profit is negative but then it goes positive. So we could find out exactly what is the break-even point by doing a goal seek. We've done that on several occasions in the past. So data, what if analysis, goal seek. So what we want to do is we are looking for this cell to be 0 because it's our break-even point by changing demand. So it's going to change D. It looks like D right now is a little too high. We're already past that break-even point. But if I click OK, what it's going to do is it's going to go find the exact number of units associated with 0 profit. Now, of course, you can't sell a fraction of a unit, so the profitable demand, the first break-even point would be 932, because if you sell 932, you get a little profit. If you sell 931, you've lost money. So 932 is the least number of units you can sell per month to be profitable. And then if we look for our other break-even point, it looks like it's somewhere between 3,500 and 4,000. So let's do another goal seek here. So data, what if analysis, goal seek. And my goal is that I want this cell to be 0 by changing demand. Okay, so I'll let it rip. And so our last profitable demand is 39.18. Because 39.18, we get a little bit of revenue, but if it was 39.19, we're losing money. So 39.18. All right, now what about if we want to maximize our profit? We can't do that with what if analysis, but we can do it with solver. So let's give that a shot. That's maybe a little advanced. Let's go here to the data tab, and I've got the solver turned on. You may not see it there if it's not turned on, and search on YouTube. I've got a video for how you can turn on solver, enable it. It's not tricky. But let me go to solver here, and it brings up a menu. So what I want to do is I want this to be maximized. Okay, so that's already selected. and I'm giving it permission to change this value. So in some ways it's similar to what's happening with goal seek, but the difference is I don't know the specific numerical value I want the profit to be equal to. I just want it to be as high as possible by changing demand. So now when I click solve, it goes out and finds that. It finds 24.25 is the optimal demand. And that's, I think, what we had solved for with the paper calculations as well. So I'm going to click OK to save that value. All right, so we found the range of profitable demand. So let me put some conclusions here. Conclusions. The optimal demand is 24.25 units per month. The range of profit demand is 932 until 3918. So that's the range of profitable demand. And what if we want to do a graph of this? Let me insert a figure here. I'm going to do a scatter chart where I smooth the lines and I don't show the individual data points. So let me choose that chart type, and then I'm going to select some data here. So right-clicking, select data, add a series. So on my x-axis, if I want it to look like this figure, on my x-axis is going to be demand, and on my vertical axis, let's do revenue for this first one. Okay, so on the x-axis is demand, and on the y-axis I want it to be revenue. So it should be that nice curve like we saw before. Oh, there it is. It looks good. Okay, that's good. Let's add another one. Let's add, oh, by the way, maybe I should label that as revenue. Give me the chance to call that revenue. All right. Now I'm going to add another one. I'll call this one cost. And so in the x-axis, again, it's going to be demand. And on the y-axis, I'll put cost. Okay, so there's that cost curve. All right, now let me add another one that is profit. On the x-axis, we'll have demand, and on the y-axis we'll have profit. Now it's going to radically change the figure when I do this because I've got some negative values there. We can adjust that. See how it's now changed the scale? Let's take a look at this curve so far. Pan down a little bit. All right, so we need to do a little bit of fixing up on this. First of all, I want to turn on some axis titles, and that'll allow me here to note that this is demand, number of units sold per month. And then on the vertical axis, this is amount of money. All right. And now I'm right-clicking on the vertical axis, and I'm going to format that axis because I don't want it to go down into the negative range. I just want it to show only starting at 0. And that looks a lot better now, going from 0. So basically, you only see here's the profit, here's the revenue curve, and the cost curve. I'm also not entirely satisfied with the horizontal axis, so I'm going to right-click there, format axis. I'll start that at 0, and maybe I'll just, let's see, the range. Maybe I'll just have that display through 6,000. Okay, so that's looking okay. So we've got demand, amount of money, and then might as well add in a legend if I can. So legend. Oh, and since I named those series, it's automatically labeling it for me. So I think that's a pretty good figure. You know, it has that same classical shape. Maybe we don't need the x-axis to go quite so high anymore, the vertical axis any longer. Maybe 6,000 would be enough. 600,000. All right. So what we wanted to do in this demonstration was just show how we calculate the break-even points, maximize profit, and put together a graph that illustrates the relationship between how many units we're selling and what's the profitability. And how smooth that curve is depends on whether we had a sufficient number of data points along the way. Like if I just did 0, 1,000, 2,000, 3,000, it may not be as smooth as it is here. So you want to have enough data points so that it's able to have a nice smooth curve. All right, that's it. If you have questions, just let me know. Take care.